Hi everyone, my name is Lydia and this is what I wish they taught me about econometrics and introduction. In this video, we're going to talk about why logs turn changes into percentages, a little bit of an intuition and also a few numbers to convince you of this very nice property of the logs that we are basically using. So if we start from the main key idea using the log function, if we draw a very nice picture here, we'd have a number 1, and this is where x is. Here we'd basically have ln of x as our y. The ln function would look something like this. Okay. Now, let's check some actual numbers and let's see what the log does to those numbers. So let's look into ln 300. So if you use a calculator, you'll find out that ln 300 is actually approximately 5.704. And if you take ln 303, approximately, that is 5.714. If you take a few more numbers when you have your calculator out, and you can check this for any numbers that you want, really. Let's say ln 600, that's approximately 6.397. And let's take ln 606, which is approximately 6.407. And one last ln, let's say 1000, and ln 1010. So 1000 is approximately 6.902, and 1010, 6.918. Now, what have we done exactly with all of these numbers? So there is a bit of a pattern in here. These are not just randomly asking you to find some numbers. Well, I've picked randomly ln 300, 600, and 1000. The next number that I've asked you to find is not that random. It's actually intentional, because going from 300 to 303, just as a number, basically I have increased this number by 1%. Going from 600 to 606, I've increased this by 1%. From 1000 to 1010, I've increased this number by 1%. Okay? So everywhere that I'm going from these numbers is a 1% increase. Now, what has happened to the actual numbers? Well, if you use, again, the calculator and to find the changes that are happening in here, is that these are by 0.01. This is 0.01. This is, sorry, this should have been an 8, 0.01. Okay, so as you can see, when I have changed my ln function by 1%, so the number in the ln function by 1%, the actual numbers that the ln is giving me is changing by 0.01. And basically, what we can take away from here is that a 1% increase in x produces approximately the same increase in ln x regardless of the level of x. So it didn't matter if we had ln 300 or ln 600 or ln 1000 and increasing from there by 1%, the change in here was consistent 0.01 or 1% in all of those cases as well. And this is a key numerical insight. Now, basically what we're doing in here is we're saying that, well, if I have some xg in, so some x here, and then I have some x1 plus g in here, and I'm finding the actual changes in here on the ln one, then this approximately should be the actual g that I have introduced as a difference. So mathematically, we would write that ln of x1 plus g is equal to, using here the ln properties, this is just ln of x plus ln of 1 plus g. And the crucial property here is that this ln 1 plus g is, if the g is very small, then this is approximately simply g, which means that the ln x times 1 plus g minus ln of x, so the difference between those two, approximately is this g, this small increase. So the g, keep in mind, is the percentage change in x. Okay, so when x increases by g%, which is why we wrote, which is why we wrote this as 1 plus g. So when x increases by g%, ln x increases by approximately g%, or by approximately g. So that's the entire reason the log differences are approximated to percentage changes, and the coefficients in log models measure percentage effects. I hope this video was helpful, and I'll see you in the next video.